Well, this is Barry, VK2FP, and as you can see behind me here, I have acquired a iRadio UV98. It's the same as the Radtel RT8800. Now it transmits anywhere between 18 MHz and 1000 MHz. However, you can only use it on the 2 and 70 centimetre band because the harmonics are within the FCC acceptable range. But what if I want to transmit on 6 metres with it? Well, I'll have to filter the harmonics out, won't I? Now, if I go transmitting right now on 6 metres, I'm likely to get a knock on the front door from the local radio inspectors, and I haven't got enough tea and biscuits in the place to feed their appetites, while I explain to them what am I doing transmitting on the FM broadcast band, or in the United States, your FCC inspectors. So what am I going to do about it? Well, here is my iRadio UV98 hooked up to an external antenna. So I can transmit. I can't transmit on any of those bands displayed there because of the harmonics. So how am I going to fix it? With a quarter wavelength coaxial stub hooked into a T-piece, and that will ultimately go onto where my antenna will go to. So how do I know what length of coaxial stud should I use? Well, a piece of coax on a quarter wavelength, an open quarter wavelength, is actually a short circuit to the frequency you're trying to trap out. So I want to trap out 104 megahertz. So I measured out some coax at 104 megahertz. The length is 76 centimeters or thereabouts. Take into consideration velocity factor, and it comes down to about 47 centimeters. So how am I going to measure that? With my trusty VNA. So here is my trusty nano VNA, and I have cut it to a quarter wavelength on about 100 megahertz, but I haven't taken into consideration velocity factor, so we'll get rid of that scale here. Right, now you can see where she dips here. She's dipping at about 64 megahertz. So she's dipping at 64 megahertz, and she's dipping down at minus 30 dB. So that should work quite nicely at cutting out that harmonic I don't want. First of all, I had to calibrate the nano VNA. So what I did was I used these. There are plenty of videos on YouTube on calibrating nano VNAs. So I have the length of coax here, and it's actually 75 centimeters long, and at 64 megahertz, when I calculate the velocity factor, it's actually 64 megahertz. So this coax at a velocity factor of 66% actually works quite well. So now I'm going to trim this piece of coax, and I will see what the nano VNA, and I will trim it down to 104 megahertz, and then using that T connector I'll be able to transmit on 6 meters. But before I do that, of course, I'll have to measure the harmonics using my tiny SA spectrum analyzer, which is how I measure the harmonics on these things. So as you can see, we've dipped here at 64 megahertz, minus 30 dB of attenuation, which I'm notching out using this piece of coax. Well, I will cut. I need to cut quite a bit off it, so I will cut probably about 5 centimeters, 10 centimeters off it, and say spectrum analyzer. Now these quarter wave stubs are quite good. I used one on an aircraft once because I'm an avionics aircraft engineer. We had FM interference coming through on the aircraft VOR. So what we did, the FM station that was interfering with the aircraft VOR, the VOR frequencies on the aircraft were between 108 and 118 megahertz, and they're receive only. So what I did, was I cut a notch to the FM broadcast band, which is what this is, and I put the stub in, and it cured the problem. Of course, I submitted it to CASA for approval, and was already part of their pre-approved list for doing such repairs on general aviation aircraft. So here we have a quarter wave stub cut to 103.5 megahertz, which will stub out transmission on the 6 metre band. But I'll have to check this on the Tiny SA spectrum analyzer, but I will show you that in another video. This is Barry, VK2 Foxtrot Papa, AG7VC, in beautiful downtown Heathcote. And on this really hot day where the mercury's hitting 40 degrees now, so it's quite hot. See you later everyone, VK2 Foxtrot 73s. This is Barry, VK2FP, demonstrating how a quarter wave shorted stub can eliminate the second harmonic. And now I can use my iRadio UV98 on 6 meters, that is. So I'll show you the outcome. So here is my iRadio UV98 tuned to the Wollongong repeater on 53650, hooked up to a rubber ducky antenna, but you may note there is no stub on the antenna. Ooh, that's not good. Alrighty, I've just transmitted, and look at that second harmonic. Where are we? We are at minus 7.7 dB, below the fundamental frequency, and that is on 105 megahertz. And that, by the way, was the International Space Station you heard in the background there. He's just doing a pass overhead. So thank you, ISS. I won't contact you today, not while I'm doing this video. So that is the second harmonic. As you can see, you're going to get a knock on the front door. What was that? Wasn't an RI knocking, was it? Ah, okay. Anyway, I'll show you the results with the stub. Now, here is the iRadio UV98, and it has a quarter wave stub, which is about 46 centimeters long, taking into account the velocity factor of 66%, and it is now tuned to a quarter wavelength at 103 megahertz. So let us go inside and look at the Tiny SA spectrum analyzer and see the difference. Look at that. The fundamental showing here is minus 7 dB, and what's it showing on the second harmonic, which is on 103 megahertz? Minus 41 dBm. So it has notched out. It has notched out 35 dB of harmonic. Now that is within FCC specifications. So the quarter wave stub does a marvellous job of being a notch. So there you have it. You can see the Tiny SA spectrum analyzer with the quarter wave stub. This thing here has effectively, we can now effectively use this cheap handheld, the iRadio UV98. Damn good radio, really excellent airband receive, 1,000 channels. So now I want to use it on a field day on 6 meters, and I do have a proper rubber ducky antenna for it. I can now use it. So this is VK2 Foxtrot Papa. Thanks for watching my video. So if you can do that for any frequency you like, if it's generating harmonics, or if it's causing FM interference, or if you're interfering with another frequency, a quarter wavelength on the frequency that it's interfering with is the answer to your problems. 73s, and thanks for watching. This is VK2FP. Cheers all, 73s.